This is lesson 26, and it's the division algorithm. They give you a 4-step method. I'm going to give you a 5-step method. Again, I've been teaching a long time and learned that this extra step really helps things. So divide, multiply, subtract, check, and bring down. And I remember that some people say, does McDonald's sell burgers? I always say, does McDonald's sell cheeseburgers? So I put that extra check cheese in there. So when I'm writing a division problem, this is my dividend, my divisor. So 852 divided by 3. I don't know if you can see it, but I put little lines to keep my columns separated. If you wanted to, you could turn your paper this way and then you have columns for you. And that's really helpful because it is so important to keep everything in the correct column for the correct place value. Okay, so when I'm dividing, what I'm saying is, how many times will 3 go into 8 without going over? So how many groups of 3 can I make? And I'm just going to go place value by place value by place value. What I'm really saying is how many times will 3 go into 800? But let's just think of it as 8. So 3 will go into 8 2 times. So I've divided. 8 divided by 3 is 2. I'm going to multiply. 2 times 3 is 6. Okay, so now I'm going to subtract. I'm going to check. Is 2 less than 3? Yes. So I can bring down my next number. The reason I check, if that's bigger, this means you haven't done your part of your quotient correctly. Okay, so now I'm going to ignore this whole problem and just move on. I'm going to say, oh, how many times will 3 go into 25? So 3 times 8 is 24. So I've divided. 8 times 3 is 24. I'm going to subtract. I'm going to check. Is 1 less than 3? Yes. So I can bring down my next number. And you notice how I'm keeping everything lined up? Okay. So let's bring that down. Will 3 go into 12? Yes. 4 times. 4 times 3 is 12. And I have no remainder. So what I'm saying is 852 divided by 3 is 284, or 2 hundreds, 8 tens, and 4 ones. Isn't it weird that you can divide by breaking it down into place value? There's a couple of different algorithms. There's a partial quotients algorithm that maybe we'll explore at some point. A lot of you learned it if it's Common Core math. It's kind of handy. This is the 5th grade algorithm, so they want you to learn how to do this correctly. It may take practice for some of you. Some of you may not have even had this. Some of you have had it a lot. So this is where I see some parts of math kind of breaking down. When you get to decimal numbers, this is much easier to do than partial quotients or partial products. So we'll work on this. I'll show you the other one at some point, but I'll check with Mrs. Snyder first. Okay, example 2. They want you to look at this, and it says a group of teachers is planning a field trip for 234 students. They have 5 buses. So how many kids are going to go on each bus? Can each bus carry the same number of students? So we look at this, and I know if my number ends in a 5 or a 0, it will not have a remainder, but this does not. So I know I'm going to have a remainder here. So let's use my same algorithm. Divide, multiply, subtract, check, and bring down. I'm going to start here. Will 5 go into 2? No. So I put a little X there just to tell myself, nope, I don't have anything in that place value in the hundreds place. So I move on. Will 5 go into 23? So I'm just going to look place by place. And yes, it will go in 4 times. So 4 times 5 is 20. So I divided, got 4, multiplied, got 20. I'm going to subtract, and I get 3. Is 3 less than 5? Yes. So I can bring down the next number. Okay. Will 5 go into 34? Yes, 6 times. And I have a remainder of 4. So what does that tell me? Remember, this is how many kids I had. This is how many buses I had. So it looks like I can't divide them into 5 equal groups, can I? So it looks like I'd have one bus with 46 and 4 buses with 47. I could spread them out that way, depending on if they were all good friends. That's how they wanted to ride together. When you have word problems in division, you have to think about what that means. So you may be able to do the math. Think about what it's telling you, okay? Listen, 26 again, example 3. This one looks like fancy math, doesn't it? 5n equals 365. So you're starting to get into some algebra stuff, which is really cool. All that means is 5 times some number that we don't know. So 5 times n equals 365. So think about your fact families. I can say 5 times n equals 365. I can say n times 5 equals 365. Or I can also say 365 divided by 5 is n. 365 divided by n equals 5. So which one is going to give me what n equals? This one right here. N equals 365 divided by 5. Okay, so I'm going to write my problem down here. I'm going to use my same algorithm. Put it over here so you could see it. Will 5 go into 3? Nope, so I'm going to put a little x there. Will 5 go into 36? I'm going to keep moving over till I find something that it can go into. And yes, it will go 7 times. So I've divided, now I've multiplied. 7 times 5 is 35. Now I'm going to subtract. Is 1 less than 5? Yes, so I can bring down. Will 5 go into 15? Yes, 3 times. So that's dividing. Now I'm going to multiply. Subtract, check, and I'm good. So 73. Okay, so I know that 5 times 73 equals 365. Could I check that? Sure. 73 times 5. So 5 times 3 is 15. There's my 1 goes over there in the tens place. 5 times 7 is 35 plus 1 is 36. So I've done it correctly. That makes sense? Let's go back to this one just a minute and figure out how to check that one. When you have a remainder, it's a little bit harder to check, but not much. So here I'm saying that 5 times 46 plus 4 is 234. So let's see. 46 times 5, 30, 23, 230. Wait, oh, there's my 4. Okay, so plus 4 equals 234. So check, I got that one right. So if you have a remainder, you just add it on in the end. Does that make sense? Okay, good luck with this. I think you can do it.